Okay, here we go. 8.4 binomial expansion. This is the first half of the lesson. The second half you'll find in the tutorial right underneath it. So let's go ahead and look at your notes, and you've got three rectangles. And in the top rectangle, I want you to go ahead and take the binomial x plus y and go ahead and square it. So that means expand the binomial. So pause this video, expand it in your rectangle, and come back and let's check your work with mine. All right, so either you remember that nice shortcut that says square the first, twice the product of the two, and square the last, and you didn't have to expand it by hand, or you wrote x plus y twice, and you distributed the x and you distributed the y, and you got that. So all right, that was our first binomial expansion of the day. Let's go ahead and do it again. Let's take the binomial x plus y, and let's raise it to the third power. So you can do this by multiplying what we just got, the x squared plus 2xy plus y squared times x plus y. Just go ahead and pause this video, do it, and then we'll come back and check with me and see if you've got the same thing that I have. All right, so hopefully our answers align. If not, go ahead and pause the video and see where you made mistakes. Does anybody want to do x plus y raised to the fourth power? Yeah, I didn't think so, right? And especially wonder if we saw on a test x plus y to the 12th power. That would be very time consuming and in a wasteful way. So what we're going to do is we're going to look at some expansions that someone else already did, and we're going to see if we can find some patterns. So this was a lot of fun in class where pretty much all the students came up with the patterns that exist. So go ahead and pause this before I start talking about the patterns and see if you notice some things. All right, so now that we're looking at this together, one of the patterns that the students noticed in class was, let's take this x plus y to the fifth power, is that we always started, our first term always had the x. And so it was always x raised to whatever power the binomial was raised to. And then as we moved along, it went down by one, down by one, down by another one, until it just went away, right? Because x to the 0 is 1, and that's why that last term doesn't have an x in it. And then they noticed that the opposite was true for the y term, that it started at the very end, and it was always raised to the binomial's power. And as we move from right to left, moving to the left, it decreased, its exponent decreased as we kept moving until it finally was gone. So that was a really cool thing that people noticed. Let's see, what else did students notice? They noticed that, let's pick a different, let's pick this binomial raised to the sixth power. They noticed that no matter what term you look at, the exponents in that term added together always equal the binomial's exponent. So you can see that's true, right? 3 plus 3 is 6, and 2 plus 4 is 6, 5 plus 1 is 6, and just plain old 6 is 6. Students also noticed that there was a symmetry to all the coefficients. So when they looked at the coefficients, they saw the first and last were always 1. And then the second and the second to last were always the same, in this case 7, right? So there's this symmetry going on, and we'll talk about that symmetry with the coefficients later. But let's go ahead and go back using that third rectangle, and we are going to go ahead and expand. We're actually going to expand the x plus y to the fourth. And this is how we're going to do it. We're going to first take care of the variables, and we'll come back and talk about what's going on with the coefficients. So with the variables, we're just going to leave a blank, and we'll come back. And so we notice that we always start with x, and it's always going to be raised to the binomial's power. So we'll say x to the fourth. And what I'm going to do is I'm going to assume that we also notice that there was no y in the first term. And so I'm going to go ahead and put plus, put a line for the coefficient that we're going to fill in later. And x is now going to be raised to the what? To the third power. I'm going to leave a space for y and come back and do y, okay? So coefficient, leave a line, that's x squared. Leave a space for y. Leave a line for the coefficient, that's x. Leave a space for y. And then finally, we're going to start with y because x is gone. So I'm going to switch colors, and I'm going to do y. I'm going to start from the very right, and y at the end will always be raised to the power that the binomial is raised to. And as I move to the left, it's going to decrease by 1 each time until it finally goes away. So wow, that was quick, right? Now we need to fill in the coefficients. So we need to notice a pattern with the coefficients. And so instead of looking at all the expansions that we just looked at, we're going to talk about something that's called Pascal's triangle. So back in the day, and I wish I knew my history better, but back in the day, people were great thinkers. They weren't just mathematicians. They were great thinkers across all subject areas, and they spent a lot of time thinking and noticing patterns and trying to come up with rules that could help us in cases like this, if we wanted to expand a binomial, to do it much more quickly if they could come up with something, right? Lots of pressure on them. And you know what? They had the time to do this deep thinking because, do you know why? They didn't have iPhones. So anyways, right? The little drum roll. All right, so here we go. Pascal came up with this game. I'm just going to call it a game. And he said, you know what, let's think about a pine tree, all right, which is very symmetrical. It's got a point at the top, right, and it comes down. And he said, just let's start this game with a 1 at the top and a 1 on either side. And let's let the rule of the game be that when you see two numbers in a row, we're just going to add them. So let's see, 1 plus 1 is 2. And you put the answer right in the middle and right below. But he saw a problem because his game was already done, right? So he said, well, let's continue this game. Let's go ahead and keep putting these 1s on the side. And once again, thinking about a pine tree. We're going to make it symmetrical and keep going out a little bit more with each row. And so we can keep playing the game. 1 plus 2 is 3, and 2 plus 1 is 3. And once again, put those 1s out there. 1 plus 3 is 4, and you're like, Miss Overby, why are we doing this? Hold on, and you'll see in just a second. So we're going to keep playing this game, and keep playing the game. Oops, 16, 10 plus 5 is not 16. All right. I'm going to play the game one last time. You have room on your notes to keep playing this game. I don't have a calculator on hand, and the numbers are going to start getting pretty big. Let's see if I can play it one more time. 8 and 28 and 56 and 70. All right, this is going to be my last line. Feel free to keep going. All right, so Pascal did this, and then he noticed, these coefficients look familiar. And so if we go back to those binomial expansions done for us, right? Look at these and look at your notes, what you just wrote. Do you see 1, 3, 3, 1, and 1, 4, 6, 4, 1, and 1, 5, 10, 10, 5, 1? So cool, right? So now let's figure out how to use Pascal's triangle. Basically, we see the 1, 2, 1. That represents x plus y squared. Now, I keep saying the binomial, the first term of the binomial is going to be x, and the second term is going to be y. Obviously, we're going to see different terms in the binomial, but for the rules, we're just going to let x represent the first term in the binomial and y represent the second term. So if you want to know the coefficients when you expand x plus y to the second power, there you go. If you want to know the coefficients when you expand x plus y to the third power, there you go. And as you move down, it makes sense, right? They're the ones we need for our fourth. We're going to go fill those in just a second. And as we work up, I know these look kind of funny, but wonder if it was just x plus y to the first. It's just 1x plus 1y, right? So those are our coefficients for that. And this is x plus y to the 0, because anything, even x plus y, because it's a quantity together, raised to the 0 power is always 1. And so you keep going down, like, etc. You get this. So let's remember these numbers because we're just expanding x plus y to the fourth power. 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. One more. All right, and we're going to add these to our binomial. Let's pick a different color. 1, 4, 6, 4, 1. Now, do we need the ones? No, but I think our notes are for our future selves, and so let's just put that in there, and we can always simplify. We're done. Was that so much faster? I mean, I know we had to pause and do Pascal's triangle, but We're done. Way better than expanding. And so what we're going to do before we stop this video and move on to the next video is we're going to talk about how Pascal's triangle is great, but wonder if somebody asked you to expand x plus y to the 20th power, right? It's like, ooh, that's a big triangle. And we may make mistakes along the way and end up with the wrong coefficient. So we need another way too, because this is a great way. If you've got anything from, the second all the way to the 8th power, the Pascal's triangle is the way to go. But past that, we want to be able to have a different method. And so here we go. Here we've got x plus y to the 15th. And right, same thing. We're not going to use Pascal's triangle. So here's the deal. First, I want you to stop for a second and see that big rectangle that's in the middle of the page. A lot of people, no, I shouldn't say a lot, some people like to know the notation or the rule. And so if you want to pause a video and write this down in your in that rectangle, feel free. This just gives you a rule for what we've been saying. And if you look at it, n represents the binomial's exponent, and then you'll see like follow x. X would be raised to the binomial's exponent here, and then 1 less than the binomial's exponent there, right? Keep going until all of a sudden it's gone. So this puts into writing, into notation, what we've been talking about. If you don't want to do that, don't do it. If you can understand it just by example, then that's awesome. All right, but, whoops. But let's see if I can get back to where I was. Okay. All right. So I'm going to introduce you to something called NCR. So NCR is actually, you can reach it using your calculator. We're going to use it when we do probability and another few lessons. And C stands for combinations. So we can use, when we have two numbers, which we're going to talk about two numbers, we can use this. This is combination. For example, let's say that you were wondering, you have 5 differently decorated cookies to choose from. Nope. Sorry. There's 5 chocolate chip cookies on a plate, and you're wondering how many ways you could pick 2 of them, right? That's how we would use NCR when we're talking about probability or counting principles. But right now, we don't have any cookies on the plate, and we're just looking at an expansion. So when we talk about NCR, we are talking about N standing for the binomial's exponent. And so when we go to, let's see what's behind here. All right. So when we let's say this is, we'll go back to the, I know I'm doing a lot of back and forth, but I'm trying to help you make sense of things. Right. Let's go back to the one that's raised to the 4th power, and I'll keep going back. Okay. So what I want us to do is know that we could have come up with this number by doing NCR. And we'll stop and I'll tell you what N stands for. N stands for the binomial's exponent. So in this case, it's 4. Okay, so this is going to be 4. And this, the R, stands for the y's exponent. So in this case, the y, there is no y, right? So it's 0. So I'm going to use a different color. Another way to get 1 is to do 4C0. Now, how do you know that 4C0 is 1? You pick up your calculator. And this is what you do. The first thing you're going to do is you're going to press 4. So if you have to pause and go get a yellow calculator, that's awesome. Do that. So you're going to push 4, and then you're going to push PRB, so that's our probability button. Then you're going to scroll down and you're going to see the NCR. You're going to push that. Then you're going to push your 0, and then you're going to push enter. And when you're done with that, out should pop a 1. Okay? I know that's a lot of button pushing, but it'll be faster once you get used to it. And so here, another way to get 4 would be to say, okay, what's this term's NCR? Well, n's always going to be 4 for this expansion. And then this time, y's exponent was 1. So 4c1, if you pick up your calculator and hit all these buttons and enter, you'll get 4. And here, this is going to be 4c2. And this one is going to be 4c3. So I'm showing you a way to find those coefficients if it's too big to use Pascal's triangle. All right? All right, we'll talk about the combinations a lot more when we do counting principles together and probability. Let me make sure I covered everything. I tried to split these videos in 2. This was just a setup. Let's see if so once again, n is the binomial's exponent, r is y's exponent, and also you may every now and then see, instead of NCR, you'll see these big parentheses with the n on top and the r on the bottom. It means the same thing. So just in case you see that, just know that it means the same thing. All right, I think we're moving on to examples, and that's in my other video. Thanks for joining me. I will see you in class.